We identified over 300 chemicals or chemical mixtures that have been reported to use for hydraulic fracturing between approximately 2011 and 2014. That's a large number of chemicals to evaluate, which is part of our job, was to look at associated hazards and risks with chemical use. There's some aspects of that. It's a kind of a scary number, but a lot of these chemicals are used very infrequently. So there's a smaller number, approximately 50% have been used less than 10 times, at least reported use. We also looked at matrix acidizing. So there's very little information, public information available on matrix acidizing and the kind of chemicals being used. We looked at some reporting that's done in the southern part of South Coast Air Quality Monitoring District. And we were able to identify approximately 80 chemicals that are associated with matrix acidizing use, including hydrochloric and hydrofluoric acid, which are injected really to dissolve the rock. It's not injected under pressure, so it's a little bit different process. And approximately 1/3 of those chemicals were not on the prior list we had developed in terms of whether they're hydraulic fracturing chemicals. So there are some other things going on that need to be further clarified in our opinion. Probably the most outstanding point to make, unless we want to get into all the details of chemicals, which I love to talk about all day, but I won't bore you with. But there's a lot of information is missing. And with looking at these chemicals, first of all, 300 is a lot of chemicals to try to evaluate at once. There was a lack of information on basic information we refer to as an environmental profile, things such as it biodegrades, whether it persists in the environment, or things like whether it's toxic or not. And an example of that is to look at, there's standardized tests for getting this information on chemicals. Some cases it's required, for instance, for pesticides, they're required to make these types of measurements. And you end up looking at, showing here is looking at acute toxicity, so it's a pretty radical test. You look at whether fish, when exposed to this material, die, or mice, or other kind of animal. And it's kind of a basic beginning point for these environmental profiles. And if you look at the chemicals being used, there's about 2/3 of them, one way or the other, there's an incomplete profile on these chemicals. So from the scientist's point of view, trying to answer the question in terms of what the risks and hazards are associated with it, without the proper amount of information, it's very hard to really answer that question in an authoritative manner. Well, under current structure, the way the United States operates is these measurements are not really required. They're only required when, for instance, it's a pesticide and it falls under TSCA, or if there's some bad thing that happens, like when the Elk River spill, they just didn't have this basic information, so it was kind of a crisis. They needed to develop it very quickly. So just, some of the information is available to industry. They use it for development of things like MSDS sheets, but it's not necessarily put in a public forum where it can be vetted to see if it's good quality measurements or not.
Thank you.
Or how it mixes or interacts with other chemicals.
Yeah, and that's another complication. Moving on to produced water management, and I'm glad to answer more questions about chemistry as people want to go. One of the things I think people know, but just to make sure everybody's on the same page, is in California, when you produce oil, you're actually producing a lot of water at the same time. And I've heard various numbers, but the number people like to say is 10 times as much water as oil. And that water is managed in a number of different ways, essentially as either a wastewater or as a resource to be reused. And we'll talk about that. What's important, the relation between the chemicals we talked about and this produced water, is that based on all of our analysis, it is very likely that produced waters from these fields that are being fractured contain hydraulic fracturing fluids or their breakdown products. So there's a lot of reactions that occur underground, but then those chemicals are pumped back out so that those chemicals are mixed in with produced water. So looking at produced water management is an important aspect of managing hydraulic fracturing impacts.
And the produced water is from the water that was used to generate fracking plus groundwater or other water that they've encountered along the way?
So the water from the formation with the oil plus the water that's been injected containing typically large concentrations of chemicals.
Okay.
And one of the questions is we don't really know what the return period is, and I'll get to that in a little bit on when those chemicals come back. We're not clear about that. So in terms of the water, so the produced water comes back up, and as I said, it most likely contains some of these chemicals or degradation products of those chemicals. It's disposed of or managed in a number of different ways, and this pie chart shows the proportions, but a lot of the water in this pie chart in particular is looking at water just from hydraulically fractured wells. It's not overall water management by the industry. It's just looking at hydraulically fractured wells. And according to the records, a lot of the water, more than half of it, is being put into so-called percolation pits or percolation ponds. And these pits are designed specifically to infiltrate groundwater. There's also, actually I jumped ahead on my slide, I think, on the,
Excuse me. If these are designed to infiltrate groundwater, what is going into that groundwater? I mean, we know that the produced water contains chemicals, many of which are carcinogenic and toxic. So that's a cause for concern, unless I've misunderstood your observation.
I would tend to agree with that.
That's why the 2,500 wells are being investigated, and the concern brought up in the report is percolation ponds as well.
So were there any regulations about where this water was going? In other words, are they doing just what was deemed acceptable, or are they actually in violation of some regulations that we had in place that would prohibit percolating and what have you, so that these chemicals end up in the groundwater?
I'm not really an authority on regulatory structure.
We can ask the State Water Board. They're coming up following.
Excellent, thank you.
So I jumped ahead a little bit on this slide, is that this water being produced, there are three major ways of disposing of it, which is the percolation pits. There's also subsurface injection occurs, and then there's various kinds of beneficial reuse. And in California, that also includes use for irrigated agriculture. So going back again to where it's going, there's a lot of the water from the hydraulically fractured wells that is reported to go to percolation pits. They're not really functioning as evaporation ponds. They're designed to infiltrate the groundwater into the ground, the produced water into the ground. Just as a caveat, the industry people that looked at the report are suggesting that that data is not particularly accurate, but that is the data that's being reported, that they're actually changed their practices. There's the second most frequent disposal is looking at subsurface injection, and we'll talk a little bit about that. And then there's a data gap that's identified as that approximately 20% of the produced water from the wells, it's just not being reported as anything in particular. So from a scientific point of view, it's very hard to evaluate something that's reported as other or is just left as a blank field. So we identified that as a data gap. So when we talk about disposal to percolation ponds, if people can see the figure, the red dots are active percolation ponds that we know are active, and this is from State Water Board data. The yellow ones are ones that we're not sure what their status is, and then there's a number of inactive ponds. There have been ponds that have been closed particularly. What we can see from this is if you look at the blue, is there is water that's identified as fairly high quality, reasonably shallow groundwater. And you can see, at least we can see because I'm used to looking at these maps, is where the red dots are, they're up gradient of where the blue water is. And then there's also kind of a lack of information of what's going on directly under the ponds in terms of.
Locate where that is? Is that primarily the Central Valley?
Yeah, it's the southern Central Valley, San Joaquin Valley, and on the right side would be approximately the Bakersfield area, and then the highways are Highway 5 and 99 coming together at the base.
And way over on the left?
That's
Ventura?
Ventura, Santa Maria.
Santa Maria Basin.
Those wells are all in northern Santa Barbara County. That you see
The red.
overlap between the red and the blue, and that's a concern because that is Senator Jackson and my county, and we're a little concerned, particularly that your report said that wells are currently under review for inappropriate disposal of into protected aquifers, and that those are likely to have included fracking fluids, which you just indicated we don't know the full health effects of. And so it comes to mind what can be done to deal with the groundwater that has potentially already been polluted, and what can our regulators do to provide a greater degree of protection for groundwater from those impacts of oil and gas.
And after, maybe he briefly responds, if they're almost finished, and then we'll have Q&A, but if you'd like to respond to any of that right now,
Well, I'd like
feel
to,
free, and then this is the
Senator
co-chair of
Williams,
this hearing, so,
Senator Williams just made the presentation for my next slide,
okay, good.
which is we're moving from the percolation ponds, which there's a lot of questions on that from a scientific point of view about whether that's a good procedure. We look at disposal injection wells, and injection wells in general are considered a preferred practice from an engineering point of view and environmental protection point of view, but there is the caveat that deep injection wells, the so-called Class 2 wells for disposal, need to be properly sited and designed, and this goes towards what Mr. Williams just said. What we have here is a picture of it's Elk Hills Field in particular, but the red dots are injection wells that they're not sure about whether they're sited properly and adequately protecting groundwater, which is exactly your point, I believe. And then the black dots are showing where hydraulically fractured wells are. So based on this kind of analysis, it's pretty apparent that materials from the hydraulically fractured wells are being introduced into these deep well disposal wells. The blue dots are ones that are all the wells, and then the ones that are red are the ones that they're not sure they're properly sited. And it's, as you say, there's probably legacy effects from this. Even if we stop these practices, we need to start looking at legacy effects. Going on to the third major reuse of produced water is looking at beneficial reuse. And, from a scientific point of view, people are encouraged about doing, water management, efficiency, reuse. But we did not find that there was any particular regulatory barrier that would prevent hydraulic fracturing chemicals or their products from being mixed in with water that's being reused for irrigation. So it's probably hasn't happened yet, or it's happened on a very small amount, but there's no real structure that says it can happen in the future. And if we're going to reuse produced water, especially from hydraulically fractured areas, we need to make sure that we're measuring the right kind of chemicals. Right now, we don't really necessarily have the appropriate monitoring in place. There's questions about whether the treatment that's currently being used is adequate. That needs to be determined. And in general, put other kinds of safeguards that are standard for reuse of water of this type.
So your point is that only a small amount of our food may have been poisoned. And so we better put a regulatory structure in place before a large amount is. Okay.
The one thing to remember, so when we want to bring this up about, there's a lot of question about the wisdom of using percolation ponds. There's also, the assumption that if we start not using percolation ponds, we're going to use some other procedure, and that we just need to keep in mind that there are trade-offs that will occur if we start changing our water management practices. One aspect that was talked about, I think, in previous committees, but there's a question in some areas that with deep well injection, you end up inducing seismicity. We were not able to see evidence of that in the scientific study that was done under the auspices of SB4, but it is something to consider when looking at trade-offs on different disposal practices. Excuse me.
There's some water there, I think.
Thanks. So from the study, and very briefly, I laid out the details. We came up with some major recommendations. One of them is basic, is to limit the use of hazardous and poorly understood chemicals, and they potentially disallowing chemicals that don't have full environmental profiles. So they just get the information, it's not that difficult to get, and make sure you have that information before you start using the chemical. Basic idea is to apply green chemistry principles, which is to reduce the overall number of different chemicals being used, which is kind of a daunting task. 300 numbers is 300 chemicals, a very scary number. To reduce that makes it much easier to manage. When you get the information on what the environmental profile is, you start making choices about picking, if there are two chemicals for the same purpose, pick the one that's least hazardous. And then there are chemicals that just really do not have good environmental profiles, which most importantly would mean that they would persist for a long time in the environment if released. And those kind of chemicals should be discouraged from being used altogether. In terms of produced water management, the number one recommendation may be to characterize the chemistry. We really don't understand if or how the water chemistry from a fractured well may differ from studies that have been done on normally developed wells. We need active monitoring programs to really try to understand if these chemicals are being injected, are they coming back out, and when are they coming back out. If the percolation pits or ponds are going to be continued, there needs to be some kind of control program for that so that the water potentially is treated or at least is understood better before it's put into the ponds, or you could phase out that practice. When you want to reuse water, we just need to include hydraulic fracturing chemicals and chemicals, more diverse chemicals in general, than what's being monitored right now, and looking at appropriate treatment trains. And there is an analysis in the report on what might be adequate pre-treatment before reuse in the for hydraulically fractured wells. And again, going back to what Senator Williams said, was looking at the legacy impacts, and others have said, you know, whatever we do going forward, we still need to consider what we've done in the past, and especially percolation ponds and improperly sited wells. There's potentially a significant groundwater contamination problem that needs to be considered. We need to determine if there's a relationship between wastewater injection and earthquakes in California. That has not been fully investigated in California. It's something of concern to people. And then again, this goes towards evaluating trade-offs. You know, what other risks are going to be associated, and also what are the opportunities for beneficial use. There's our ways, some of the water that's being produced is pretty high quality in terms of salt content, and there are opportunities that the water could potentially be reused.